Welcome to our first video of Know Your Chemicals series, where we dive deep into the world of chemical compounds that shape our everyday lives. Today, we're going to take a closer look at hydroxyethyl cellulose, or HEC, a remarkable water-soluble polymer that's widely used in industries like construction, cosmetics, and pharmaceuticals. Whether it's a new skincare product, shampoo, or a paint, HEC is a key ingredient you'll find. Before we dive into the properties and production of hydroxyethyl cellulose, let's first understand its building blocks. The story begins with cellulose. Cellulose is the main chemical building block of plant cell walls. It's what gives plants their strength and structure, much like how bones form the skeleton of animals. It's one of the most abundant naturally occurring compounds on Earth. But, just like many compounds, cellulose starts with some small, simple building blocks, carbon dioxide and water. Through the process of photosynthesis, plants convert these molecules into glucose, a simple sugar and one of the simplest forms of energy. A glucose molecule has a ring-like structure and is one of the basic building blocks in nature. The term monosaccharide literally means one sugar, mono meaning one, and saccharide meaning sugar. When many of these glucose molecules bond together, they form a long chain, creating a polysaccharide, which simply means many sugars linked together. There are two main types of glucose, alpha glucose and beta glucose. The key difference between them is the position of the O group on the first carbon atom. If alpha glucose forms a chain, it's called starch and it serves as an energy storage compound. But when beta glucose forms a chain, it becomes cellulose, a substance that gives plants their structure, much like the role of a skeleton in humans and animals. Beta glucose, when it chains together, forms a unique structure due to an inverted arrangement between the first carbon of one glucose molecule and the fourth carbon of the next, creating a beta-1,4 glycosidic linkage. This is a critical difference between starch and cellulose. Unlike starch, which tends to branch out, cellulose forms long chains that are tightly bound together by hydrogen bonds, creating strong fibers known as microfibrils. These fibers help plants retain water and maintain their strength. That wraps up our deep dive into cellulose, the first building block of hydroxyethyl cellulose. In our next video, we'll unlock the secret of ethylene oxide, the second key ingredient that gives HEC its unique properties. Stay tuned for the next episode of our Know Your Chemicals series and follow us for more updates.